Utility, a numerical indicator of a person's preferences in which higher levels of utility indicate a greater preference. The table illustrates an example of utility that an individual gets from consuming two goods, grapes and bananas. We will use utility to identify combinations of goods that are more preferred to other combinations of goods. To do this, we assign a higher utility value to bundles of goods that are more preferred. Looking at the table, the sample consumer prefers 4 pounds of grapes and 1 pound of bananas. The utility value of 25, to 1 pound of grapes and 2 pounds of bananas, with a utility level of 23. With combinations of goods that give exactly the same level of utility, the consumer is indifferent between those two combinations. For example, the sample consumer is indifferent between 2 pounds of grapes and 2 pounds of bananas, and 1 pound of grapes and 3 pounds of bananas, since both combinations yield the same utility level of 27. One thing to remember with utility is that utility is ordinal. The value of utility is used solely for ranking combinations of goods and services. We cannot make the conclusion that a bundle with the corresponding utility level of 20 makes a consumer twice as happy as with the bundle with the utility level of 10. A budget constraint is an income limitation on a person's expenditures on goods and services. It tells us that expenditures on all goods and services can only be equal to or less than a specified amount or a budget. Suppose a pound of grapes costs $2 and a pound of bananas costs $1. If you have a spending limit of $8, then the combination of 4 pounds of grapes and 1 pound of bananas is beyond your spending limit, which is a total cost of $9. Similarly, the combination of 4 pounds of bananas and 1 pound of grapes is under your spending limit with a total cost of $6. This graph shows the total cost of purchasing the different combinations of grapes and bananas. The graph on the left calculates expenditures with bananas and grapes costing $1 per pound. The graph on the right calculates expenditures with bananas costing $1 per pound and grapes at $2 per pound. On this figure, combinations that cost more than $8 are shaded in red. Comparing the two graphs in the figure, notice that an increase in the price of grapes increases the number of combinations that are shaded in red, resulting in fewer combinations of bananas and grapes that are affordable to a consumer at a spending limit of $8. Suppose you consume only two goods, hot dogs and Coke, and your budget for both goods is $75. A hot dog costs $3, while a bottle of Coca-Cola costs $1.50. This table shows a list of possible combinations of hot dogs and Coke that exhausts your budget. Looking at this graph, the slope of the budget line equals the relative price of a hot dog, which is equal to opportunity cost of one more hot dog. Looking at the graph on the left, this shows an effect of a decrease in the price of hot dogs. Looking at the graph on the right, this shows the effect of a decrease in the price of Coke. Utility maximization is an assumption that people try to achieve the highest level of utility given their budget constraint. To understand utility maximization using our example of grapes and bananas, we need to combine the utility information with the cost information from the previous two figures. This table shows two of the same graphs as the previous figures, but with the red shading consistent with figure 5.3. The red areas still identify the combinations of grapes and bananas that are beyond the spending limit of $8, given the different prices of grapes and bananas. From the figure, the source with the bold number identifies the affordable combinations of grapes and bananas that gives the consumer the highest level of utility at a given price of grapes. The graph in figure 5.4 is the utility maximizing combination. It's 4 pounds of grapes and 4 pounds of bananas, given that the price of grapes and bananas are $1 per pound. On the right side of graph 5.4, the utility maximizing combinations is 2 pounds of grapes and 4 pounds of bananas, because the price of grapes increased to $2 per pound. We can see that if the consumer were utility maximizing, then an increase in the price of grapes from $1 to $2 per pound, holding the price of bananas to $1 and the spending limit to $8, will induce the consumer to decrease the quantity demanded of grapes from 4 to 2. If we illustrate this change on a graph with the price of grapes on the y-axis and the quantity demanded of grapes on the x-axis, then what we have derived is exactly the price and quantity relationship we now know as the demand curve. The increase in the price resulted in a movement along the demand curve from coordinates 4, 4 to the coordinates 4, 2. A change in income, and hence the budget or spending limit, will shift the demand curve to the left. To illustrate, suppose the spending limit decreases from $8 to $5. If the prices of bananas and grapes remain the same, then a closer look at figure 5.2 and figure 5.3 will show that the utility maximizing quantity of grapes demanded will drop from 4 to 2 if the price of grapes were $1 and 2 to 1 if the price of grapes were $2. The reason why the increase in the price of grapes and or any good results in a decrease in the quantity demanded of that good can be broken down into two effects. One, the income effect of a change in price, and two, the substitution effect of a change in price. The income effect is the amount by which the quantity demanded falls because of a decline in real income from a price change. An increase in the price of one good, holding the price of the other good and the budget constant, reduces the spending power of the original budget. You cannot afford as much, making it seem like the income has dropped. Similarly, a decrease in the price of one good, holding the price of the other good and the budget constant, increases the spending power of the original income. You can now buy the same bundle and still have extra, making it seem like the income has increased. The substitution effect is the amount by which the quantity demanded falls when the price rises, exclusive of the income effect. An increase in the price of one good, holding the price of the other good and the budget constant, makes that good relatively more expensive. So we tend to switch our spending away from that good and buy more of the good whose price remained the same. A decrease in the price of one good, holding the price of the other good and the budget constant, makes that good relatively less expensive. So we tend to switch our spending toward that good and away from the good whose price remained the same. Marginal benefit is the increase in the benefit from or the willingness to pay for one more unit of a good. This table shows a hypothetical example of how we calculate marginal benefit. From this table, marginal benefit of consuming the third unit of X can be calculated by taking the difference of the willingness to pay 2 unit of X and 3 unit of X. In this case, the marginal benefit of the third unit of X is $3. Observe that the marginal benefit of consuming one more unit of X diminishes as more of X is consumed. The demand curve can also be derived from the information on the marginal willingness to pay for a good. To proceed, we will plot into a graph the quantity of the good on the x-axis and the dollars on the y-axis. This is illustrated on this graph. An individual demand curve is a curve showing the relationship between the quantity demanded of a good by an individual and the price of the good. To derive the demand curve, one must simply compare the willingness to pay with the price of a good. For example, on this graph, if the price of a good is $2, then the consumer will want to buy the first and the second unit because the marginal benefit is greater than the price. The consumer will not want to buy the third unit at that price because the marginal benefit of $1.50 is less than the price of the good, which is $2.